Sairam students, this is chapter number 2, data representation part 3. Okay, in this we are going to discuss the last number system, that is hexadecimal. Previously we have discussed octal number system. Today we are going to discuss about hexadecimal number system. In hexadecimal number system, children, we use base 16. I told you previously also, instead of base we can use word radix. We can use word radix. Okay, understood? So let's see what is there in this. Now it has 16 possible digit symbols. That is why we are using base as 16. Okay, because in this we are having 16 digital symbols. Like in binary we are having 1 and 0. That is why we are using 2 as a base. In decimal we are having 0 to 9 numbers. It means total 10 symbols. So that is why we are using base as 10. In octal we are using 0 to 7, means 8 symbols. That is why we are using base as 8. Okay, it uses the digit from 0 to 9. So in hexadecimal system, when we talk about hexadecimal system, in numbers from 0 to 9 participate, and from alphabet A to F participate. So what is the meaning of A here? A means 10. What is the meaning of B? B represent 11, C represent 12, then D represent 13, E represent 14, and F represent 15. Okay, so 0 to 9, 10 digit, then 11, 12, 13, 14, 15. Total 16 symbols participate in hexadecimal. That is why we are using base as 16. Now let's see positional values in hexadecimal. Now in the previously, in every number system we have checked what is the exact positional value. Okay, in the chart, in the same manner, like we are having number between that one point is there. So this is the leftmost side and this will be your rightmost side. So anything which is at the rightmost side comes with the negative power, and at whatever coming in the leftmost side will come with the positive power. So we are using base as 16. That is why unit place is 16 power 0. Then tens place is 16 power 1. Then 100 place is 16 power 2. Then 1000 place is 16 power 3. In the same manner, in the rightmost side also we follow the same pattern. So here 16 power minus 1, this is your 10th place. Then you are having 100th place, that is 16 power minus 2. Then you are having 1000th place, that is 16 minus 3. Then 10,000th place, that is 16 minus 4. I hope you are getting my point. Then what is the need of hexadecimal? Application of hexadecimal number system. The hexadecimal number system is used in computer to specify the memory address. Which are 16-bit and 32-bit longer. For example, like in your computer you are having memory address in the binary form. See, computer always deals in binary. So that big binary number contains lots of combination of 1 and 0. So it's a big address, children. So that is not possible to remember easily. That is why instead of that big combination of binary form, we can use hex number system, that is easier to understand. So instead of this big So instead of this big binary number to learn as a memory address, we can convert into the hex number system that is easy to understand. Like D6A5 is easy to understand in comparison to this 11010101010111. Okay. Now let's see another application of hexadecimal. Hexadecimal number system is used to represent color. Now in computer, many times we use color codes. Like in HTML, if we talk about, if you have learned in 10th standard web designing, there we use color coding for background, for font, for anything where we want to change the color. So there we can use code also, like FF represent white color, 80 can represent gray color. So in this way also we can use hexadecimal number system. Okay, now like in every number system we have done the conversion, we have done conversion in different way, like binary to decimal, binary to octal, octal to binary, octal to decimal. In this way we have done the conversion. In the same manner we will do conversion in this also. Like first conversion is decimal to hexa conversion. So if a number is present in decimal form in the base of 10 form, how we can convert into hex conversion? So decimal to hex conversion can be done using the repeated division by 16. So when we are converting with binary, we are doing division with 2. When we are doing in octal, we are using 8. When we are doing in hexa, then we use 16. Okay, so let's see the example. So 423 is a number which is at the decimal place, and you need to convert into hexadecimal. So what you need to do, you need to divide by 16 every time. So let's see how you can do exactly. See, now 423 is given to you like this. Okay, so divide by 16. So 26 into 16, you are getting 6 6 ja 36. Then 2 into 6 is 12, 13, 14, 15, 156. Then 6, then 2. So you will get 6 plus, you will get 6 something, means 16 into 26, you are getting something, and you are getting remainder like 7. Okay, again you are dividing with 16, you are getting remainder 10. So 16 1 just 16. So 26 minus 16, you will get 10 as a remainder. Now 16 can't be divided by 1, so you shift 0 here and shift this 1 here. So we are writing from the lower side, you are writing from the lower side. So what will be there? 1a7. 1a7 is a hexadecimal form of this 423. Okay, now let's see the next example. Next example is 240. This is a decimal number. You need to convert into hexadecimal. How you can do that? By dividing by 16. 214 divided by 16. 16 into 13. What you are getting? 16 into 13. You are getting, let me give you answer for that. Okay, 16 into 13 is 208. 208. So 214 minus 208 remains 6. 6 is a remainder. So 16 into 13 is 208. Remainder we are writing here. Now 16 can't divide this 13. So it gives you directly 0. And this 13 shifts here. So I told you that like you are having 10. 10 can be represented in the form of A, 11 can be represented in the form of B, 12 can be represented as C, and 13 can be represented like D. So we are having 13 remainder, so we can represent like D. So we again represent from the lower side D6. So instead of 214 in decimal, you can write D6. So this is a simpler one to read. I hope you are getting my point. Okay, now Next conversion is hex to decimal conversion. Next conversion is hex to decimal. Now hexadecimal number is given to you. You have to convert into the decimal form. So when you have to convert into decimal form, you need to use the positional value chart. Like, let me give you example in the notebook, children, for this. Okay, let's see. We are having number 356 in the hexa form. Okay, so you have to convert into the decimal form. How you can do that? Like this, we start from this unit place. How? Like 6 into 16. Why we are using 16? Because 16 at the we are having hexadecimal number, that is why. So power is 0. Now this 5 is multiplied by 16 power 1, then 3 multiplied by 16 power 2. So this, when we solve this, we get 768. When we solve this, we get 80. When we solve this, we get 6, because 16 is having 0 power. So anything which is having 0 power, it should be equal to 1. Okay, by solving that, you will get 854. By adding all these three terms, you will get 854. So now it is converted into decimal form, children. So next example, we are having 2a5. We are having 2a5. We have to convert into again decimal form. So let's see what is the meaning of a means 10, and what is the meaning of f? Let's see. A, B, C, D, E, F. A means 10, B means 11, then C 12, 13, 14, then 15. Okay, now so F means 15. So let's start with f. F is 15 multiplied by 16 power 0, plus a is 10 multiplied by 16 power 1, plus 2 multiplied by 16 power 2. Okay, so this gives you 512, it gives you 160, it gives you 15, so gives you 687, like this. So in this way you can solve all the questions very easy. You need to start from the rightmost side when you are having such kind of numbers. Okay, now we are having binary to hexadecimal conversion. So you are having binary number with you and you need to convert into hexadecimal. How you can do that? See, children, this we have repeated. We are doing repeat this question, like we have done binary to octal. I told you that in octal we need to make 3 bits pair. Okay, so in hexadecimal, instead of 3 you have to make 4 bits pair. How you can make this? Let's see again this question in the notebook. See, you are having question 1010111010, and this is in the binary, and you need to convert into which number? Hexadecimal number. So how you can do that? You need to make 4 bit pairs. Okay, so let's make this 4 bit pair. Write again this question 1010111010. So how you can make pair? From the rightmost side. So 1 2 3 4 that come in one pair. Now 1 2 3 4 that come in one pair. Now this now only this 10 left, but it is not in 4 bit pair. You have to make it 4 bit pair. How you can make it 4 bit pair? By adding 2 zeros here. Okay, like this. Now every 4 bit number you have to convert into binary. How you can do that? Now I'm taking this one first, 0010. I told you that you can check in the table also, that I have explained you in the last video, or you can easily convert also. Like how? 0 into 2, like 1 into 2, then 0 into 2, and 0 into 2. So give power 0, 1, 2, 3. It gives you 0 into 1 gives you 0, it gives you 2, it gives you 0, it gives you 2. It means it is a binary of 2. So instead of this you can write 2. Now what is this? 1 0 1 1. Let's see that. 1 0 1 1. 1 into 2, 1 into 2, 0 into 2, and 1 into 2. Now give power like this. 1 2 3. You get 1, you get 2, you get 0, you get 2 to the 4, 4 to the 8. 8 plus 2 is 10, 10 plus 1 is 11. So instead of that you can write 11 easily, but we can't write 11 because we need to convert into hexadecimal. So 11 can be represented in a form of B. Now 1010, I'm not finding out the exact decimal for that. I know it is a number for A. A means 10. Okay. So what is the hexadecimal form for this question? That is 2BA. So this will be your hexadecimal form. So in this way you can easily find binary to hexadecimal. Now let's move to the next question. See, next question again we are having in the binary but in the decimal form, and you need to convert into hexadecimal. So again you have to divide into 4 pair, like this in 4 pair, this in the 4 pair. Now this like see 0 1 0 1. So for these digits are having 4. Last two ones uh, are not in 4-bit, so you need to make it 4-bit by adding these zeros at the end. Okay, so again find out the binary of this, find out the decimal number for binary this. Again like this, like this, like this. So these 4 digits represent 10, these 4 digits represent what they represent 14. Okay, so it represents 14. So then we are having 5, then it represents what it represents 12. Okay, so in this way we can easily find out what is the hexadecimal form for this binary. Okay, so now let's see, again we are having one more example. Now this example is in hexadecimal form, and you have to convert into binary form. How you can do this? See, 3BF5C. So write the binary of 3 for that. Write the binary. B means 11. F means, what is the meaning of F? 15. Write the binary of 15 here. B means 11. Write the binary of 5 here. C means 12. You need to write the binary of 12 here. How you can find out like 12 binary? You can find out like this. 2 2s are 6, then 0, 2 3s are 6, 0, 2 1s are remainder 1. So 1 1 in the lower side, 1 1 0 0 is the binary of C. So in this way individually you can find out the binary, and at the end write in the combination form. Like initially these numbers is the leftmost side of the decimal, so these binaries like this come in the leftmost side and remaining come in the rightmost side of this decimal. Okay, so with this our today's topic is done. So I will come with new topic from same chapter in the next part. Till then, take care of yourself and try to solve all these questions again and again in your notebook. After completing this chapter also, I will provide you proper notes from the same chapter. Okay children, thank you.